Hey guys, my name is Sarah. I am a 11th grader in Ms. Cranfield's Algebra 2 class, and today we're going to be talking about properties of logarithms. And logarithms can kind of come off as something that's really scary, that's kind of impossible to conquer, and it is one of our hardest units here in Algebra 2, but once you get to know the simple properties of logarithms, there are a lot of really cool things that you can do with them, and they become something that you quite come to enjoy as a math student. So we're going to talk today about some of the properties of logarithms to help you better understand it. So first of all, let's establish what is a logarithm. So a logarithm is an equation whose parent function looks a lot like this. So if you take a logarithm, then the parent function is going to look like f of x equals log something of x. And usually there's a number down here that it's log of something of x. So that's the basic parent function. This is the parent function of a logarithm. So that's what a standard logarithm looks like. And so once we learn the properties of logarithms and all that they have about them that we can use, then we're going to be able to solve like complex equations like these two here. And we're going to come back to these and use all of our properties of logarithms together to solve complex problems like this. So the first property of logarithms is called the product rule. And the product rule is basically kind of what you're going to do when you have a log that has a multiplication in where that x would be. So if you remember back to our parent function of logarithms, our parent function is f of x log of x. So what we're going to be looking at in the product rule is when that x right there has two components, like in this problem right here, in ln of x of y. So basically what we're going to be talking about in the product rule is what we're going to do what we can do when we expand that out. So basically what the product rule is saying is that when you have a logarithm like this, you can actually simplify it. You can expand it out to a larger form if you're expanding. So what you do and what you're allowed to do is when you break apart a logarithm and you break apart these parentheses, you will then add the two components. For instance, if you took this equation here, ln of x of y, that would equal, when using the product rule, ln of x plus ln of y. And that would be your final answer. See how these two components went to these components out here. It's kind of just like distribution, and you put a plus sign in the middle because I always kind of think of it as, because it's the product rule and because it's multiplication versus addition, which is what we have here. It's usually going to be a positive. So I always kind of think about it as we're not taking anything away as we would be in, say, the quotient rule. We are multiplying, therefore we are using addition to separate it out. So that's kind of how I remember the product rule. So let's take a look at this next example. We have log of 2 is 3, 8, and c. So this, as you can see, is what I kind of first look at when I start solving these problems, has 3 different parts. So we should have 3 different things separated by addition signs. So we have 3 different items separated by addition signs now, according to the product rule. So how would we expand this out? Why don't you pause the video and try on your own, and then I will explain it. So how we would expand this out is we would take each component and make it separate items. We would separate them. So for instance, we would take log of 2, which you always keep this, always keep the base, log of 2 of 3 plus, because remember we're doing the product rule, so we use addition, log 2 of a. And you can put these in parentheses. If it's not more than one product, usually you can keep them out of the parentheses, but I just like to for clarity. It's not required, but it's always a safe rule to have. So plus, one more plus, log 2 of c. And sorry I went on to the next line there. But as you can see, again, these elements went out to all their respective parts. And their addition signs separating them. Alright, so that's about it for the product rule. We're going to move on to the quotient rule. So as I mentioned earlier, the quotient rule is just kind of how it sounds. As the product rule deals with multiplication, the quotient rule deals with quotients of division problems. So basically, just as we talked about how adding and multiplying in the product rule, we're going to use quotients, division, and subtraction in the same way in quotient rules. So division and subtraction go together because they're taking away. So, for instance, in this problem right here, what we're going to do is we're going to separate these two parts of the division problem into different parts that are set off by a subtraction sign. For instance, we're going to take log 4 of x minus 8, which is in the numerator, minus log 4 of 2. And that's going to become the quotient rule. That's what the quotient rule allows you to do. It allows you to separate with a subtraction sign this division problem. It's a way of expanding that. Alright, so why don't you pause the video on your own and try and do the second one. Alright, so now we're going to go over the second answer. So, this second problem, how would you do this? How would you use the quotient rule? Well, you would take, again, the base, log 11 of, and this, actually, you're going to have to use the product rule as part of your, one of the tools in your toolbox to solve this problem. So basically, you're going, this kind of, so the numerator and denominator separate out, correct? You have this part and this part, but see, this has a product. So therefore, you have to split that up with addition signs, just like you did in the product rule. So you have log 11 5 plus log 11 x minus, as the quotient rule says, log 11 q. And that is the quotient rule. So see how we have this big part, which corresponds to the numerator, and this big part, which corresponds to the denominator, separated by the subtraction sign. Alright, let's go on to the power and the change of base rules, our last two rules. We are almost done. You're almost a master at logarithms. Okay, so our power rule, excuse me, it's the product rule. Power rule. So the power rule is dealing with exponents, as it might sound, because these are logs to the power of 7 and 4. So what the power rule basically says is that when you have a power, an exponent in a logarithm, then you have to move that when you are expanding into the front of the problem. So take the first example. You would move this 7 to the front. So you would say log 7 of 3, 7 log 3, excuse me, of x. And that would be your final answer because you have 7 in the front. Now, because you cannot have powers in an expanded log, we can take that out and put it up front. Just as we did in the first problem, we're going to do it with the second one. So, we're going to put that 4 up top in front. And then we're going to have our log of 9 and our x. And that's the product rule. Pretty straightforward. Power rule, excuse me. Now we're going to move on to our change of base rule. So all the change of base rule is basically it's used a lot when we're using our TI-30 multi-view calculators to enter these logs into them, because we cannot actually use this subscript in a TI-30 multi-view calculator. So we use the change of base rule. It is also used in some of our more complex equations later on. So it's a very good rule to keep in mind, especially if you're using that kind of calculator. So basically all the change of base rule says is, if you have this kind of log equation and you need to separate it out, what you're going to do is you're just going to take this part, which is the second part, and it goes in the numerator. So you would go log 120 divided by this part, log 7. And that's all of the change of base rule is. And these are not subscripts. Not subscripts. These are actually just regular logs, just like you would write out log of x without a subscript, right? So that the base is no longer there. The base has been changed, hence change of base. All right, so now that we've gone over all of our rules, let's go back to our original equations that we talked about in the very beginning. And we're going to put all of our rules to good use in expanding and condensing some log equations. So basically, we're just going to use all of our properties. So for this first problem, you can use two properties here. I'm going to have you pause the video really quick and guess which two properties those are. Okay, so if you guess correctly, the two properties that we're going to be using of logarithms in this equation are the product rule, because that is a product, and the power rule. So what we're going to do first, I always like to take one at a time. So what I like to do first is I'm going to use the power rule first, because that just makes sense in my mind. So, well, actually, do I want to do the power rule first? No, I'm actually going to, I take it back. I'm going to do the, we are going to do the product rule first, because, I'll tell you why in a second, because I just thought about it. And it's very easy to get confused on problems like this. And actually, when I started doing them, it was very confusing for me at the beginning. So I'm going to try and eliminate that confusion for you as we go forward. So what we're going to do is we're going to start by doing the product rule. And remember, the product rule says that you can separate a multiplication within a logarithm with an addition sign. So what we're going to do is we're going to separate this 5x cubed into two parts. So we're going to have log 7 of 5 plus log 7 of x to the third. Now the reason that I saved the power rule for last is because it is quite easy to get confused and want to do the power rule first and put this 3 in front of both of these logs, when that is incorrect, because the power only belongs to the x. Alright, so the power rule only applies to this portion of the log because this exponent only belongs to this x. Therefore, we cannot put it in front of this because that is not 5 to the third power. It is only 5 plus x to the third power. So then our second step, using the power rule,